Okay. So my goal here is to build a library of linear, quadratic, cubic, exponential, logarithmic, e to the x, ln of x, sinusoidal lectures and problem sets. The last thing I want is a linear mindset, and yet I'm starting with the linear here. My goal is to do one video a day. And that's a calculus concept to accumulate. Hopefully a package, a layer a day of moving towards a good solid practice to get the foundation necessary to go up the ladder in the discipline. When the library series is done, then I'm hoping to do a series of worksheets that are in random order, because I think that'll help develop a stronger sense of mathematical thought process. And so that's the goal. And this is probably going to take a couple of years. We'll see. All right. So this is the second worksheet on linear, 9 problems that I think are pretty essential. So hopefully I've talked enough in earlier worksheets that we just do the mechanics now. All right. And I'm probably going to do them the way that I like to do them, just for speed's sake. All right. So I'll start with the first y, which is, well, I'll just start with x minus 4 minus 7. Okay, using subtraction. Here I was saying, I'll just do the mechanics. I think, all right, I'm done talking. I'm just going to do the mechanics, and you're practicing. All right, so the change in x, 4 to 95. Change in y, minus 7. How do I get from minus 7 to minus 1? I got to go up 6. All right, where's my card? Oh, I don't have to. I didn't put the computer in my card. Yeah, I'm so proud of my science card here. Maybe I should tell the science department I took it on them. We'll see if it goes missing. Since every classroom has one and this was tucked in a corner. I'm assuming this is slope intercept form. So minus 3/5 times any number, minus 6/5. And I'll add 9, which is 45/5. I hope I'm not doing the same problems as I did in linear 1. So minus 3/5 x plus 39/5. And that is the practice necessary to multiply a fraction and add a fraction. Okay, people seem to need that practice now. Okay. Name 4 points so I can see minus 7 and positive 8 seem to work nicely. 8 minus 8 is 0. And when I drop in a minus 7, negative 2/3 times 0 is 0. And I do believe 0 equals 0. So I'll change my x's by 3, minus 4, minus 1, 2. I'll stop at 2. I'll drop my y's 2, 6, 4, 2. Let's see if 2, 2 works. Well, it's a good start. 2 plus 7 is 9. 9 is a multiple of 3. 3 goes into 9 3 times. 3 times minus 2 is minus 6. And if I put 2 over here, 2 minus 8 is also minus 6. I'm moving on. Feel free in my class to show the inverse operations. It's easier for me to correct. I'll subtract 8. I'll multiply by 3. And I'll divide by negative 2 minus 18. And rather than check it graphically, I think I'll put minus 18 in here. 3 goes into minus 18, minus 6 times minus 2 is positive 12. And 12 plus 8 is 20. I'm moving on. You think I got to erase that one? So this is just pause the video and practice. And check. All right, so problem number 5. We're going to get rid of the division by 2 and 3 by finding a number they both go into. And I guess that's 6. 2 goes into 6 nicely. 3 times minus 7, minus 21x. 6 times minus 4, minus 24. 6 times 3 into 6, 2. 2 times 5x, 10x. And 6 times 6, 36. All righty, we got one line going down, one line going up. Let's find the x value at which they intersect. I'll bring the 21 to that side, 31x. I'll bring the 36. Ooh, I remember doing this problem. Oh, God, I think I'm doing the same problems over again. Repetition's my friend. But let's start writing some other problem here, just in case I've done that with all of these. In fact, I think I'll start the video over. No, we'll keep going. Let's just do 5x over 2 minus 3 equals 4x minus, let's make it Let's make this minus 5x over 2, 4x over 5, plus 7, there we go. So let's multiply by what? Looks like by 10. 2 goes into 10, 5, then it's 25x minus 30. 5 goes into 10 twice, so we got 8x and we got 70. I'm gonna bring the 25 that way, which makes 33x. I'm gonna drop 70 away, that's minus 100. Minus 100 over 33 equals x. I think I'll do this one graphically. Let's get rid of that. Let's look at this line. Minus 3, we'll call that minus 3 over 2, down 5. Got a line that looks like that, plus 7. All right, 7's probably there, over 5, up 4, that's about a 4 to 5. Does it look like that x value is around 3 or 4? Negative 3 or 4-ish? Oh, absolutely it does. I like that. Okay, we got a standard form of a line. We're gonna graph it real quick. Okay, no, I wouldn't have asked that for this one. I would have given you an easier number. Okay, so let's go 5x plus 3y equals, oh, I don't know, 45. Let's do 45, okay? So that we got some nice user-friendly numbers. Okay, this is standard form. You want the x and y intercepts, so you want to plug in value of x equals 0 and a value of y equals 0 and find the mate. If x is 0, y is 15. Boom, I know we're coming down because if this gets bigger, that's got to get smaller in order to maintain the constant. And 3 goes into 45, that's 15. Yeah, okay, I did that. So if this is 0, 5 goes into 45, 9. Okay, so 9, 0, that's 15, that's 9. 9 comma 0, 0 comma 15. And you got the equation pretty nicely, pretty carefully, and pretty easily. And you could have gone up another 9. And you could have gone down another 15. Those numbers are going to work as well. Parallel and perpendicular. All right, well, we already tell, if you're looking for the patterns here, 9/2 is perpendicular, which means negative 2/9 has to be parallel. But let's see why. Let's go for the parallel. 9y equals minus 2x. We don't care about the 20, it's a constant. Y equals minus 2 over 9. There's the parallel. I want it to go through negative 5.97. So y equals minus 2/9. X plus 5.97, which means when I drop that in, the whole side disappears. And by magic, called the marker, 23.458 materializes. Negative reciprocal, flip it, change the sign, 9 over 2. Let's do that one more time over here. Down 2 over 9. There's a down 2 over 9 ratio. Perpendicular looks like I'm going up 9 and over 2. All right, so 9 over 2 is the perpendicular. There's the perpendicular, and down 2 over 9, changing y over changing x, is the parallel. So 9 over 2, same thing, bring this down. I'm hitting the thermostat here, bring that down, and you got your perpendicular. All right, let's do one elimination problem, just for practice. There's about 3, 6, 7, 8. Yeah, it could be about 16 things here that we're doing. And if you make one mistake, it's hard to find them sometimes. And it takes time, so let's just make sure we don't make any mistakes. Let's get rid of the y column first by multiplying this one by 3, and let's multiply this one by 4. That'll be positive, that'll be negative, which means that 12y and minus 12y cancel. So I'm just going to go to 9x. Underneath, I got 20x. 3 times 10, 30. 4 times 7, 28. I got 29 equals 58. 29x, excuse me, equals 58. So x is 2. So the easiest way to deal with this is to plug 2 in. 6 plus 4 is 10. So y is 1. We can see that y equals 1 by checking x equals 2. 2 times 5, 10, minus 3, 7. Okay, so this works. But let's actually get rid of the 3 and the 5 here and do it by eliminating the x's and solve for y. Let's get the y equals 1. So I'm going to multiply this one by negative 5, and I'm going to multiply this one by positive 3. Minus 5, negative 15x, positive 15x, that's going to cancel, so I don't even have to do it. I won't even erase that. Minus 5 times 4 is minus 20y equals negative 50. 3 times minus 3 is minus 9y equals 21. We add that up, we've got 29. We add this up, we got minus 20. Oh, it's minus 29. Almost got careless. Minus 29. And over here, we got minus 29y. Yeah, I think y is equal to minus 29 divided by minus 29, which I think confirms y equals 1. All right, that was quick and easy. 7 minutes of practice, maybe. And we'll do 2 more of these linear 9 problems. And hopefully, you're making some gains.